Very surprising things will happen. Don't. Sometimes we need to follow. Nothing can be done. So eraser. Don't follow vivid YouTubers. This will spoil your. It's very harmful to your health. Okay, following of YouTubers. Okay. Now today's our agenda for the today is AlexNet. What net? AlexNet. Yesterday class we have seen LeanNet. What are the things was not covered in a LeanNet? LeanNet. There is no activation function as a ReLU. They have non-linearity use tan H, and also it related to the grayscale. Right? And what is the second point? There is no concept called padding. And what is not there? There is nothing called max pooling. These are the things we have seen in the AlexNet. Now, when I come to the LeanNet, this paper is published in 2012. This LeanNet is published in 2012 by famous author called. How many of you know Geoffrey Hinton? How many of you know Geoffrey Hinton? Does anybody heard about Geoffrey Hinton? No, yes. I will. Godfather of deep learning. Okay. Good. Okay. Is a guard. I will show you the Geoffrey. Somebody's you need to remember. Anne Lukun. Should not forget them actually. And look. Like your girlfriends, existing girlfriends or current girlfriends also. I'll not comment for women. I have some respect for them. He is the Anne Lukun. He also won the this one. He also won the this Oscar award. What is the last time what the Nobel Prize? He also won the Nobel Prize. He is the Anne Lukun, who is the actual made the neural network into world is Anne Lukun. He is the person. He is the massive guy. And one more guy, Geoffrey Hinton is very old. Geoffrey Hinton. This is the beautiful guy. This is see how beauty he is. I might have taken Geoffrey Hinton photo for yesterday's work. This photo is very good photo. Okay, we should not forget these two guys who has given the greater community support for AI. Right. So, what happened to the LeanNet history? We'll discuss about LeanNet. Okay. Today we will cover only AlexNet because of this time constraints. I need to catch up for my meeting, right? So we will do theory and we will close this with the practical. Tomorrow we will see VGG and some other network. Because of time constraints only. There is nothing more than this. In 2012, there was a open challenge in image processing, where they have proposed the AlexNet, where they have proposed the AlexNet. See, there are few similarities in between both LeNet and AlexNet. LeNet having of 5 layers, whereas AlexNet we have 11 layers. And here we have used max pooling. Here we are using average pooling. The depth here parameters are 60K. Here the parameters are um, I would say 60 million parameters. But here compared to the LeNet, compared to the LeNet, your AlexNet having depth of layers. Depth of a layers. Here the LeNet is having how many layers? We have only 5 layers. So here we have used the what is the major improvement to this? ReLU is came into picture because of what is the ReLU activation function? This is what ReLU, where no negatives in a network, no negative values for your activation, after your activation. So it will avoid dying of a neurons, vanishing gradient problem. Some of vanishing gradient problems. Right? Now we will see. The AlexNet was being employed by the 8-layer neural network, won the ImageNet large-scale visual recognition by 2012 by a large margin. Actually, it outperformed the all the competition. It outperformed to all. This was done by who? Is by Geoffrey Hinton. If you want to say AlexNet history, AlexNet deep learning written by. Okay. Here I'll show you. Yesterday I have done some bookmarks. Here is the paper of the AlexNet. If you can see, AlexNet, this one. Um, see, AlexNet is named the name of the convolutional neural networks designed by Alex Krzyzewski and published by and doctoral advisor of Geoffrey Hinton. Who is this? Geoffrey Hinton. So there was a work by the Geoffrey Hinton. And trust me, surprisingly, Geoffrey Hinton was recently published a paper on capsule net, and which is telling that there was a wrong approach we followed by using max pooling in convolutional neural network. That was his statement. I'll show you his statement on the max pooling. Now you see this. Can someone read it? Can read this paper? Lokesh, can you read this?
Hello, sir.
Huh.
I just came.
Yeah.
Yeah. The pooling operation. Wait. Are you getting, sir?
Pooling operation? Yeah, we are not audible.
Hello.
Yeah.
The pooling operation used in CNN is a big mistake, and the fact that it works so well is a disaster. If the pools do not overlap, pooling loses valuable information about where things are. We need this information to detect precise relationship between parts of an object. Yeah, it's true that if the pools overlap enough,
the position of features will be accurately preserved by coarse coding, but I no longer believe that coarse coding is the best way to represent the pose of the objects relative here. I think that it makes the more sense representing the pose as a small matrix that converts the vector into the positional coordinates into relative use into positional coordinate relative itself. This is what they do in computer graphics, and it makes easy to capture the effects of the change in viewpoint. It's also explain the why we cannot use the shape without imposing the rectangular coordinate frame. So convolutional neural networks has no explanation for that, or at least none of can think of it. This was the paper. If you read this sort of articles by authors, what you will feel, you will go mad. Literally, you will go confused. What is happening? This guy said this guy is the person who introduced. This guy was introduced about this one, and now they were telling that it will not be useful or good. Okay, let's keep this way to some extent, further some extent. Okay, and so when now that statement is that pooling layer concepts itself, he was claiming now it's a mistake for a convolutional community. It's not my word actually. Okay, please don't take that Suresh's class was telling that max pooling is a wrong option. No, it's not mine, and it was given clearly by the researcher who has written this paper. That you should understand. So for time being, assume that we don't have the other option. All neural network models are being with max pooling. You accept it or not, max pooling is the key component which extract the data which have a relatively significant to each other. These features are correlated. Okay, this is how AlexNet. Now we will see. AlexNet consists of how many layers? 11 layers. The following architecture. One of the most reputed computer vision challenge 2012, right? ImageNet challenge. and result are significantly better than compared to the previous solutions. Because of the reason is the major reason for outperforming this work is even this one I can share you the link actually. This one. You can read it. Recent one only. It's not like one. It's maybe somewhere down the line. What's wrong with CNN? It's 2017.
महात्मा गांधी से बड़ा
Guys, who is this? Even you can read these articles. You should know complete background of like it's not about only knowing only CNN, Max Polling, ImageNet, this one, AlexNet or GoogleNet. You should know complete essence of any architectures. This is what I emphasize here too. You focus on the more areas, more important. Here the picture came into us ReLU. See, now we could see. Now today it was my effort got reduced because of this diagram. The initially I have a image. It's a RGB image because I have a 3 here. I have a taken image of 227 by 227 into 3. 227 by 227 into 3. And how many filters I have? 96. So I'll get 96 filters. Okay. Now this will change as stride of convolutional of 11 by 11. So 227 minus 11 plus 1, right? Stride of 4. Stride of 4, right? So what will be the size here? What will be the size? 228, 11 minus. Is this formula correct or wrong?
It's wrong, sir. +1 should be not
Sorry?
there. It's wrong, I think, sir. +1.
N minus F plus 1 by S, right?
I think n minus f by s and +1.
N minus
Floor of n minus f by s.
N plus 2 plus F by S plus 1.
Yeah.
This is what the, okay, padding is 0 right now.
Yeah.
So padding is 0. Now you calculate now.
No,
N
sir,
equals
N plus 2b minus f by s plus 1.
that is what I have done, sir. 11 by S. How much will be the S is 4, right? So what is the value I'll be getting here? 216 by 4, right? 5, 4 plus 1. 55 I got. So this one, next step was I made it as 55, 555 into 96. So again, what is the concept here? Max polling. Here in convolutional, they applied what they have applied? They have applied the ReLU. When you are applying 50 by 55, 55 by 55, here I don't think so padding. Here no padding concept here. So it has been translating into 27 by 27. Max polling will give me the, it's this value I am getting here. Then again, for pooling layer, we won't use the padding. Maximum, we won't use the padding. Again, there was convolutional with 256 filters. Stride of 5. 27 minus, how many? 5 by 5 plus 1, right? So 20.
$23.
Again, padding is 2, right? So same padding, right? I have used the padding also. N plus 2p minus f. Right. N plus 2p. 27 plus 2 minus f. What is the value I'll be getting? Okay, sorry. Padding it once again. Because we wanted to know whether our calculations are good. Now you see here, from here to here, are we retaining the same value? Can you calculate someone? 27 by 27. Now I have forget about the channel. 27 by 27. Someone calculate man. 5 by 5 filter. Okay. Stride equal to 1. P equal to 2. Now what is the formula? N plus 2p minus f by s plus 1. Right. Now n equal to here 27 plus 4 minus 5 by padding equal to s equal to 1 plus 1. So here this will become 26 minus 1 plus 1. 27 by 27. Right. This will result in the same, right? Yes or no, guys? Guys, yes or no?
Yes, yes.
So that's when again I am applying the max pooling. I got the values. Again I am changing the filters. In this complete picture, number of channels will be increasing, height and width is decreasing. Channels means this is the filters 96, 96, 256, 256, 384. That's how it has been like improving. So again convolutional, again padding and stride. Here, what is the difference to AlexNet to LeanNet? There is no concept of padding in the LeanNet. So finally the neurons will be connected. Then again we have a fully connected layer, and with 1000 neurons, the final will be output. AlexNet can perform the classification on 1000 classes. How many classes? 1000 classes of the data. This is the complete 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 steps. But in this, how many convolutions? We ask. One, 2, 3, 4. Sorry, not this one. 4 convolutional operations. Here 4 con operations. In the here, which net this is? AlexNet. Is this clear about AlexNet? The story of the AlexNet? If you want, you can read it.
I think it is 5, Suresh, 5 convolutions.
Where?
Here the outside one is there.
Okay. See, convolutional 55. Then max pooling. Now you see the max pooling of 3 by 3 in the stride of 2. That will be n minus f by 2p. Right? Stride of 2s. n minus p by s. So I'll be size of 27 is my output. The depth before is 94 because we have done the pooling layer for each layer. So step 3, 256 filters 5 by 5. So the original size will be restored. Like this, we continue till here. Max pooling 6 by 6 into 256. So fully connected layer. Fully connected layer. Why we are using fully connected layer? Why are we using fully connected layers? Which converts 2D into one dimensional. Are you getting the point? Why fully connected layers are used? Why fully connected layers being used? So for each layer, we have the pixels of and fed into the 4096 of neurons of the weights determined by the back propagation. So fully connected layer. This is the last layer has having 1000 neurons because of the image net have the 1000 classes to be predicted. So whereas in a LeNet, my predictions are 10 classes. Whereas AlexNet and all major nets, they have tried to predict about 1000 classes. Thousand classes of the data. This is what about complete AlexNet. So the design philosophies of the LeNet or AlexNet are similar, but there are significant differences. AlexNet is much deeper than comparatively LeNet. AlexNet consists of the 8 layers, 5 convolutional layers, and 2 fully connected hidden layers, 1 fully connected output layer. Prasad, here you see AlexNet having 5 conv nets. Second, Alex used ReLU instead of sigmoid. This is what very important. What is the difference between AlexNet to LeNet mean? It's not of the depth. It's about the major changes in this architecture is the activation function. Activation function. And second, AlexNet has changed the sigmoid activation functions to ReLU activation function. Wait a minute. So AlexNet changed the sigmoid activation function to a ReLU activation function. On the other hand, the complication of ReLU is much simpler. Computation here. On the other hand, ReLU activation function makes a model training easier when you are using the different parameter initiation methods. This is what very important. You need to keep a note on this. Write down this point. On the other hand, the ReLU activation function makes your model to train easier because it doesn't have any negative values. It will not have any values. Because when your output of the sigmoid activation is close to 0 or 1, the gradient of those regions almost to 0. So that back propagation cannot continue update the model parameter. In the contrast, the gradient in the ReLU activation function is positive interval in always. It will have the very positive interval. Therefore, the model of the parameter are not initialized. The sigmoid function will make this, and here the gradient of ReLU activation function can be positive interval always 1. Therefore, if the model parameters are not properly initialized, the sigmoid may obtain the gradient almost to 0 in the positive interval, so that model cannot effectively trained. This was the point why sigmoid can make your model to struggle. model to suffer. We should have the reasons for why it is not happening. This is what my learning, and don't think that there should be some improvement. Like the sigma here, this point we will talk about these points bit. I'll gonna clarify here a bit. Now, see here, AlexNet uses the which activation function? ReLU. What will happen to the ReLU? First, we'll try to understand ReLU. ReLU is an activation function which takes the values, which skews the values from 0 to 1. No, it's not the value. The sigmoid will be 0 to 1. If it is here, it takes the max of 0 comma f of x. If it is having a negative values in network, it is assigning to the 0. Or if it is having a value, it is taking the value 150 or whatever. If it is value, my pixel intensity will be 0 to 255. When I was computing it, then I get some value. It will be greater than 0. If it is 0 and f of x, I am operating as max operation. So this max function will making my values will not be having 0 to 1. This for sure. 0 between 1. This is the not story here. We are negative values, we are making it as 0. That's it. There is no 0 and 1. There is no 0 1 concept here. It's been ruled out. See, in the other hand, ReLU activation function makes model training easier when you are in different parameter initiation. Okay. We'll keep this as a thing that we'll write down this. ReLU will make your model to training easier. That's it. Keep that word. Model training easier. This point. You keep this point aside. ReLU. Alright. Because when the output of the sigmoid will, what is the sigmoid? 1 by e power minus x. This will result me between 0 to and 1. Again, I have negative values here. So, 0 to 1, there is a values between 0 to 1. And also there will be 0 also. The gradient of these regions almost 0. The weights of this one. Gradients is nothing but weights, right? The gradient, rate of change. What is the gradient again? First try to understand. The rate of a change. Rate of change. Till this point clear? Now, I'm gonna erase this. Now, this is the thing you need to understand whenever you want to be a data scientist. It's not about building a model. Anybody can do the AlexNet implementation. And we should understand the complexity of AlexNet and why ReLU been introduced. Now, let us understand. My sigmoid have the values of 0, 1. Okay. Now, my ReLU can have 0 to maximum. Here, I'm telling you, the gradients will almost close to 0. Gradients will, like the gradients on the in this region 0 to 1 will be always 0. When it tries to, when it back propagation cannot continue to update some model parameters. When the values are 0, my weights are 0, back propagation cannot update. And don't ask me back propagation. I believe that you know the back propagation. Okay, this is a point. Okay. Now, in the contrast, so in sigmoid, this will become a 0. sigmoid, the gradients become 0. Write on this point. Sigmoid, the gradient becomes 0. This is what one of the question asked me in the interview in like 2017 or 2018, I believe it. Round Square, the company in Hyderabad, they asked, Suresh, can you explain me why are you using ReLU? That's it. You cannot say answer as ReLU will make the 0 and 1. We should give this answer so that you can clear. I might have cleared one at that time. In the contrast, gradient of the ReLU activation function, the positive interval always 1. What will be the interval? For interval for the sigmoid, the gradient is always 0. For as a ReLU, it is always interval is 1. So I have a 1 value. So that therefore the model parameters are not properly initialized. The sigmoid okay. You once again you park this concept here. Okay, here I'm taking here the concept. Here. So this point, I'm coming to this point, this particular point of this. See, if I have a gradients are 0, is there anything to learn? Is there anything to learn? There won't be nothing to learn. Whereas in a ReLU, my value, my ReLU activation function as a positive interval always 1. Always 1. So my model can able to train properly because of the model interval. The model interval of gradients equal to 1. This is 1. So that model tries to learn. Believe me, to collecting this kind of information will take a lot of time. Actually, in fact, I was reading some more articles actually for a different purpose. Now, is this clear about what is the difference between sigmoid to the ReLU activation function? Why ReLU will be more effective here? If you not understood, let me know. I'll gonna explain you again and again. Tell me. Is it, if it is ReLU is clear, type ReLU.